Hello, my name is Dylan Kiesling. I'm a 7th grade member of the Wolfpack CubeSat development team located in Palm Beach Gardens, Florida. Our team was created in 2015 as an after-school club and is made up of middle and high school students. On our team, we learn things like orbital mechanics and work on aerospace projects such as launching high-altitude air balloons and learning how to design, build, test, and launch small satellites called CubeSats. It was our team's goal to deploy a CubeSat into space within 3 years of its creation. In 2018, we successfully completed this goal by making history as one of the first middle school teams to deploy a CubeSat into space. We did this as part of NASA's Kicked Out Launch Initiative. This year, we finished building our second satellite called CapSat-1, which launched just last week. As part of our ongoing work, we engage in numerous molecular biology projects and work on different payload ideas that could help further advance space exploration. So one of the things we are currently researching about is Xenobots, because we believe they will have great potential for applications relating to spaceflight. So Xenobots are the first living programmable nanorobots created from scientists at the University of Vermont, Tuck University, and Harvard University. So Xenobots are made entirely living tissue from stem cells and heart cells that were acquired from the African clawed frog. So to create the Xenobots, the research team used a supercomputer to test thousands of redesign iterations of simple living things and what tasks they could perform. The computer was programmed with an artificial intelligence evolutionary algorithm to predict which organisms are most likely to do useful tasks, such as moving around or pushing objects forward in their environment. So once the most promising designs were found, the scientists conducted microscopic surgery, combining the stem cells and the heart cells together. So the following year, the same group of scientists created the new generation of Xenobots. These Xenobots have advanced abilities. These Xenobots self-heal as well as self-replicate. So their self-replication is made possible due to their complex architecture. So as you can see, the Xenobot has a mouth-like shape. This mouth-like shape is able to collect other loose cells, such as a green ball, and they can assemble them together into other Xenobots. So Xenobots have the ability to self-heal, replicate, they can move as well as push objects forward, all of that innerves their brain. And this leads to numerous applications in fields like robotics, artificial intelligence, medicine, biology, but most importantly, space exploration. So Xenobots are the first living nanorobots. So nanotechnology is technology that operates at the nanoscale, where materials or devices are self-assembled from molecular components. So nanotechnology exhibits specific properties that can be programmed to perform tasks and operate autonomously. So Xenobots are such nano devices, and due to their unique properties, they can have numerous applications, not only here on Earth, but also in space. So one such application that Xenobots can have in space is these spacesuits. So Xenobots can self-assemble themselves together to bind a functioning spacesuit. They can use sensory capabilities to detect space radiation in an astronaut and prevent the astronaut's exposure. And they can also deliver medicine if the astronaut gets hurt assessing for his need. So as far back as 2005, before Xenobots were even created, scientists at the Northeastern University, Boston, Massachusetts, proposed all-terrain bio-nano. This spacesuit would be composed of 3 layers. So the outer layer, where there would be nanobots that would be responsible for sensing the outer environment. The inner layer, where nanobots would be in contact with the human body. And the middle layer, where they would be responsible for communicating between the 2 layers, signaling of danger, or even the drug delivery if needed. So Xenobots and nanobots have intelligence, and they have the ability to sense things. And so through their sensory capabilities, they can detect a cut in the astronaut's suit, and then they can self-assemble themselves and bind up to seal out puncture. However, if any harmful materials does get into the spacesuit, Xenobots from the inner layer can deliver medicine precisely where it's needed if the astronaut gets hurt. So for example, Xenobots can detect various levels of space radiation, and then they can prevent the astronaut's exposure. So another application that Xenobots can have in outer space is the ability to detect and prevent exposure to any harmful things in the environment. So as we look to colonize other planets, we need to protect our new environment. So for example, this is a rendered image of a future Martian city. So Xenobots can be linked up with the urban computing network and be programmed to detect pollutants, toxins, and novel viral particles in the air and water. And then they can alert the officials, and then the officials of the city can investigate further. So this can help remove pandemics and any other disease outbreaks. So even another application that Xenobots could have is the ability to remove radioactive waste. So as we look to colonize other planets, people need to have an efficient source of energy. According to NASA, one of the most efficient sources of energy is nuclear reactors. However, nuclear reactors leave out doses of radioactive material behind them. So radioactive material creates ions, and these ions strip away electrons from the atoms. So what Xenobots will be doing is they'll be removing the ions, which will destroy the radioactive material at the source. So one of the main applications of Xenobots that scientists are currently researching is the ability for them to enter a person's bloodstream and deliver complete certain tasks. So unlike metal or other materials used in today's medical world, Xenobots are an entirely living tissue, meaning they're completely biodegradable. So Xenobots can enter a person's bloodstream through an injection and be programmed to deliver medicine precisely where it's needed in the human body. So Xenobots can detect and destroy cancer cells, as well as go to places that are hard to reach, such as intestines, and investigate for problems. But what makes Xenobots unique for space travel is the fact that they can be programmed to do multiple tasks inside a human's body, but they can also replicate, which means they can theoretically exist perpetually, which means So as we look to go on longer space missions, Xenobots can play a big role in space medicine. So the scientists that create Xenobots call them neither robots nor animals, but rather programmable living organisms. So Xenobots are the first programmable living organisms known to man. Therefore, their applications are still mostly theoretical in nature. But Xenobots can help propel science forward by answering questions such as what can be accomplished by a collection of cells, and what is the difference between a robot or a useful replicating machine. So it is still unclear if Xenobots can even survive in space and how their functionalities will be affected by microgravity. So as of right now, Xenobots can only survive 10 to 14 days without food, although much longer in energy-rich liquid. But since Xenobots can replicate, as long as their functionalities are not affected by microgravity, they can exist perpetually. So in order to test Xenobots, in microgravity, experiments can be conducted at the International Space Station or through on-orbit CubeSat technologies. So for example, our team is currently researching CubeSat payloads that would involve Xenobots. And while this would be very good for testing Xenobots around space, the most promising experiments will probably have to be conducted at the International Space Station, so scientists there can monitor the replicated functionalities. We are currently in contact with the team that creates Xenobots, and we believe that Xenobots are very useful for space. But since they can only survive for 10 to 14 days, we would probably have to do more testing and further advanced Xenobots. So Xenobots, we would like to continue conducting new experiments to test Xenobots in space. We would like to further advance our research. Thank you for listening to our presentation.